Okay, so now for the second part of these videos, the second part of these log equations, we need to use some more of the properties that we talked about. So we had the product rule, the quotient rule, and the power rule. So for problem number 8, we have two logs that are being subtracted. So when I see that these two logs are being subtracted, that's the quotient property. So what I will do is rewrite this as one log, and subtraction goes hand in hand with division. So these things have to be divided. Now that we have it condensed down to one single log, now we can use Bay and solve these just like we did on the previous page. So this is base, answer, and exponent. So I'm going to rewrite this as 10 to the power of 8 equals x over 3. Now with a lot of these division ones, what I think is easiest, and you can do this differently, you can see that this is x divided by 3. So to get x by itself, you have to multiply each side by 3. Some people like to think of it as a proportion, so you can cross multiply. So when I cross this way, 1 times x is x. And when I cross this way, I have to do 3 times 10 to the 8th. And so again, remember, we will get some really huge, crazy numbers. So this one is 300 million. So x is equal to 300 million. Okay, so it requires us to use the product and quotient properties first, so that we can then use Bay. So when we go to number 9, I see that I have plus, so that's going to turn into multiplication. So remember, subtraction turned into division, plus is going to turn into multiplication. So I'm going to rewrite this as one log, and these two things have to be multiplied together. So 2x times x is 2x squared. Now that it's one log, I'm going to put in my base, and this is base, answer, exponent. So what I'm going to have is 10 to the power of 11 equals 2x squared. Now, a lot of this, because this is going to be a really huge number, 10 to the power of 11, just don't worry about it yet. Just use your calculator to help you solve this. So I know that to get x by itself, the first thing I have to do is divide by 2. So I'm going to put 10 to the power of 11, and then I'm going to divide by 2 and get an answer. And notice it still gives me this weird scientific notation. So I have 5e to the 10th equals x squared. Now that e to the 10th is scientific notation. So now at this point, to get rid of the square, I have to take the square root of each side. So I'm going to do square root of my answer. So x is equal to 223,606.8. Okay, so a lot of this can be done in the calculator, and remember guys, you can use Desmos for this also. Or if you have an Android phone, you can get the Wabbit app and get an emulator of this graphing calculator. Okay, number 10. Couple of things here. First of all, I see that it's plus, so I know that when I rewrite it as one log, I'm going to multiply. But I also have this 2, so we have to use the power property first that says bring this 2 up and make it an exponent. So now I have log of x squared plus log of 4. So at this point, it becomes very much like the problem that we just did. So you're going to rewrite this as one log being multiplied. So this would be a good time for you to pause the video and try to do this problem on your own. So when I rewrite this, one log, I have to multiply these two things. So x squared times 4 is 4x squared. Now I can put in my base answer, exponent. So I've got 10 to the power of 2 equals 4x squared. Now, this one's a little easier to work with because 10 to the power of 2, you should know, is 100. So I'm going to divide each side by 4. Then, to get rid of the square, I have to take the square root. So this one works out really nice because, as you know, 25 is a perfect square. Now, for these log problems, I will say also, when you take a square root, you normally get a plus or minus, but we will only ever report the positive answer because you cannot do the log of a negative number. It's a non-real answer. So you're only going to report out the positive answer. Okay. Okay, so again, here would be a good time for you to pause and try one on your own. Very similar to number 10, the only difference is going to be that we are doing subtraction, which means you're going to rewrite it as a division problem. So we're going to move up the 3. Then we're going to write this as 1 log. Log, and it's going to be x cubed divided by 6 equals 9. Put in my base. So when I rewrite this, I'm going to have 10 to the power of 9 equals x cubed over 6. So again, just like with number 8, you can just multiply both sides by 6 if you want. You can put it as 10 to the power of 9 over 1 and cross multiply. That's entirely up to you. And because this is going to be a huge number, just do as much as you can in your calculator. So 6 times 10 to the power of 9. We get a huge number. Let's see, this is going to be 6 billion. And this is equal to x cubed. So hopefully you remember now, to get rid of a power of 3, we have to take a root of 3. So we're going to take a third root. So remember, if you go to math, option 4 of your answer. So I get x equals 1,817.12. Okay, so just a couple of questions left here. Number 12, I think, is a good one. It's got 2 separate logs. However, what you'll notice is we've got an equal sign in between. So on all the rest of them, we had plus or minus. So one thing that you have to keep in mind is sometimes your logs do not start out on the same side of the problem. So what I would want to do first is I would want to subtract this expression from both sides. So I'm going to have log of 7x plus 1 minus log of x minus 2 equals 1. Now this should look more familiar. I have 2 logs that are being subtracted. So that means I'm going to turn this into division. So it's going to be 1 log, and I'm going to have 7x plus 1 divided by x minus 2 equals 1. Now what we can do is we can put in our base. This is base, answer, exponent. So I have 10 to the power of 1 equals 7x plus 1 over x minus 2. So this is one that I would definitely make a proportion, okay? Because now what I want to do is I want to cross multiply. So I'm going to have 1 times 7x plus 1 equals 10 times x minus 2. And this gets it to the point where it's a basic equation. You guys should be able to do this. We're going to distribute. And now you guys should be able to solve this from here. So I'm going to subtract 7x from each side, and then I'm going to add 2 to each side. Whoops. So I'm going to end up with x equals 1. Okay, and then the last two, just some different examples here. Number 13, you notice that this problem already has a base that is not 10. So if it has a base of its own, you use that base instead of 10. Now, what we'll also notice is this one also has a power. So there's actually a couple of ways that you can do this. What I would do is take this power out to the front. So I've got 2 times log base 7 of 2x minus 3 equals 2. So now what I can do is divide each side by 2. So I have log base 7 of 2x minus 3 equals 1. And now this problem is ready for me to use Bay. So base answer exponent. So I have 7 to the power of 1 equals my answer of 2x minus 3. And 7 to the power of 1 is just 7. So I'm going to do plus 3 on each side, and then divide by 2, so I get x equals 5. Okay, so the last one, this one's a bit tougher, but I wouldn't be too terribly surprised to see something like this on an ACT, so I wanted to throw this one out here. So this one is already in the right form to use Bay. So this is base, this is your answer, this is your exponent. Whoa. So what I have is 2 to the power of 3 equals x squared plus 2x. So now the whole point here is you have to recognize that this is a quadratic equation. 2 to the power of 3 is 8. So I have 8 equals x squared plus 2x. Now remember, anytime we solve a quadratic, we have to get it equal to 0. So I'm going to minus 8 on each side. Then I can factor. So multiply to give me 8, add or subtract to give me 2. That's going to be positive 4 and negative 2. So then my answers are negative 4 and positive 2. Now again, I said you cannot take the log of a negative number. So on this particular problem, you have to actually plug those in and see if you're going to end up with a negative number. So if I plug in, for instance, negative 4 squared plus 2 times negative 4, that actually ends up positive, so it's okay. So I would be taking the log of 8, which means I actually get to keep that one. Okay, so those are just some extra log examples using our properties.